So without further ado, I'm going to pass along to the first of our speakers, and that will be Viktor Dörfler.
Welcome everyone. My name is Viktor Dörfler, and I want to talk a little bit about myself first, so that you get what I tell you the way I mean it. Okay, so originally I'm a mathematical engineer, and as I was only good at one thing at the time, and it was learning, I continued learning for a very, very long time. So I got a degree in economics, then one in education, then an MBA, then I got my doctoral degree in management science, but 90% of that was psychology. So I have a kind of weird background. And then based on this educational basis, I built two kind of distinct career paths that got intertwined. On one hand, as a practitioner, I was doing AI development. So I was spearheading the development of a symbolic expert system between 1999 and 2004. And before and after that, I kept using AI, implementing AI, and so on. And at the same time, as a scholar, I was studying knowledge. So how people know what they know and so on. And this side got me to interview some people who are on the top of their game in science. And that means that I interviewed 20 top scientists in the world, including 17 Nobel Prize winning scientists from physics, chemistry, biology, and so on, excluding literature and peace. So then in 2017, I attended this New Scientist Live event, where I have heard Demis Hassabis giving a talk in which he claimed that DeepMind learns the same way as people do, and that AlphaGo demonstrated intuition and creativity when it has beaten Lee Sedol. And of course, I got a little bit upset with this, because it is not what I think about AI. And therefore, I embarked on a journey to spread this kind of idea of where I see the differences between the human mind and AI, what one can do, what one cannot do, and so on. So I have done plenty of talks on that. If you look at my YouTube channel, for example, you will find a few of them. And as a final outcome, I wrote this little book, which is called What Every CEO Should Know About AI. It is literally very, very small. It is about 75 pages. So it is easy to read. It is about done in 1,000-word chunk. So I really meant it for CEOs. It is completely non-technical. So you don't need any background apart from not being afraid of computers to be able to read it. But of course, it is heavy on one side, and that is philosophy and psychology. So that is heavy on that side, because that's where we get our understanding of thinking and such. Now, so if you are not speaking, yes, thank you. So with this background, I also started several research projects. And despite being a mathematical engineer, the one thing that I have never done, I have never in my life done a quantitative study. So I am a very qualitative person. So I did this with a doctoral student who is running a clinic. So she is the managing director of a clinic in Budapest, and they specialize, amongst other things, in dermatology. So she talked to a number of dermatologists, I think 19 of them in total, about their experience of using AI, if they had any, how they want to use it, if they did not have any experience, how they see it, how they think of AI, and so on. And we learned some really, really interesting things from this. And this was primarily that they see three completely different ways of how they could use AI. One way is when they look at AI as a tool, which means that it is about giving well-structured tasks that they know exactly what needs to be done. It is just too big for us to do. Okay, so it is not treating AI much else than a giant, very powerful pocket calculator, but it is a very important thing to do that. So I also did a kind of different different type of, well, it cannot be called a study really. It was more like an informal, friendly inquiry. So I asked my doctoral students who have kids to ask their kids what they think AI was. And you cannot imagine that it is really, really fun to ask kids things, because you can see what are those concepts that we mess up, and they hold on it. So, for example, one of my favorite answer was, yes, AI is fantastic. I would love to have, how that's called, teleportation. So, yes, so AI became a synonym for high tech. Okay, and we can see that, and it happens everywhere and all the time. But this is a very, very useful thing. So this use of AI works very well because we know how to formulate those well-structured tasks. It is like having a Hoover that you can call on your mobile phone, and it will clean up your flat before you arrive from your long travel. Now, the next variant is when the AI adapts to what you usually do, gets used to your habit and so on. And that's very useful as well, because you basically don't even need to ask. You don't even need to formulate a task. It will just be there. Of course, it is not done the way that a good assistant would do that, okay? So it is done more like, you remember that the smartphones were at one point called PDAs, personal digital assistants. So it is more like a super powerful PDA that does all sorts of things, prepares for you. For example, in terms of dermatologists, this would be pre-processing large number of images and preparing the various pattern recognitions in those images and so on. And the most interesting one is, I don't have the right term yet, okay, so I'm still working on that part. Here I call it now a sounding board. How they talked about this third type of use was that they would like to consult it as a colleague about their diagnosis. And it is very interesting that is usually the more experienced dermatologists who asked about that, those who have higher level of expertise. But they usually said that it should be the kids who use it. So the more junior colleagues, they were not so keen about doing this themselves. Now, the essence is that this is actually a very interesting way of using AI. So if the dermatologist comes up with a diagnosis, it would be useful if AI could critique the diagnosis based on all that pattern recognition and all that background processing that it can do. So what AI is really good at is very different from what we are good at, okay? We are good at thinking, and we are not that good at that specific part of thinking that involves calculating, okay? Especially when we need to be precise about those things. And AI is very good at that. And therefore, we can use that power if we want to get good things out of AI. And that all leads me back to the initial conceptualization of AI that Tom Davenport formulated very well when he said that AI is analytics on steroids. And yes, that's a very, very good way to describe it. It can conduct absolutely enormous amount of analysis in a short amount of time, and it can present you with things that you could not do yourself. However, then you can do many things with that as an input to your work. As I was doing these talks everywhere about AI and the human mind, I have observed a very interesting thing, and it is that if there was a conference, for example, if there were practitioners, they were always talking about what the program can do. If there were academics, they were talking about what their research was about. And if there were people who would be users in the audience, they never were really too much interested in either of these. But they were interested is, on one hand, what is in it for me? And on the other hand, what are the ethical and moral implications? So you will hear more about that in the forthcoming talks about this. But this is a very important thing, that it seems that in AI, we are just replicating the oldest probably problem of ICT, so information systems in the first place, that what is sold is not the same what is purchased. So people who are building AI, they are selling the features of AI, And people who are purchasing AI, they want to buy a solution to the problems that they have. The question is how we can match these two. And I think that matching these two means educating the users. You cannot educate the AI people enough about every single profession that they would understand it sufficiently deep that they could deal with that. However, you can educate the users a little bit about AI, what is enough for them, so that they know what to ask from the AI vendors. Thank you very much. That's all from me for today.
Fantastic. Thank you, Viktor. So yes, we will move on to our next speaker, and that will be Gary.
Okay, good afternoon. Will did introduce us as experts in AI. That's certainly not true in my case. I'm really an engineer and an aerodynamicist, and we've been using AI and specifically machine learning for the last few years, but I don't claim to be an expert. So AI machine learning is one bit of a concept we call digital engineering, and that really is the general problem. If you're in product design, you want to get your product to market faster, to beat your competitors and to do it cheaper, and to reduce risk. So some things we deal with in terms of aerospace and automotive. If you build a prototype or start selling things that don't actually work correctly, that's a very expensive thing to fix. So the trend has been to try and replace any testing, crash testing of cars or testing of rigs by simulation. And up till now, that tends to be sort of discrete bits of testing. But where we're going is, you'll have heard this sort of concept of digital twin, where reality is we take all those models of the vehicle, the individual components like the drivetrain, the aerodynamics or whatever, and link them all together. So we get something that behaves like the real vehicle. And as engineers, that gets more difficult because we have to worry about the external environment like weather, pedestrians, other vehicles and things. And the other key thing about that is that our simulation methods we use tend to be very expensive. We might take days to run a complicated aerodynamics simulation, and the digital twin's not going to work like that. So really where a lot of AI machine learning is starting to be used is to replace the expensive simulations by reduced order models, and they can run in real time. So then we can have a digital twin that actually runs in real time rather than being very slow. And hence we can predict the complete vehicle behavior very early on, rather than waiting until we get to the point of building something. So the example I'll give here is some work we did with Jaguar Land Rover a few years ago, which is, if you buy a new car and you go out on the motorway and it's a windy day, you expect it to be safe. You don't expect your car to move around on the road. And there have been a few cars that have bad behavior in crosswinds that have led to crashes. And this is a good example, you see, because you can't test this till you've built a prototype and you take it to Spain or to Belgium, to one of these test tracks you can see on the picture there, and drive your car past those fans and hopefully it behaves well. If it doesn't, it's going to be pretty expensive to fix that, to do some engineering changes, because you're quite close to selling a car. And the other thing, it's just testing one case. Those fans are fixed. And the real world is quite complicated, the way the wind goes around motorway bridges and things. So what we did was look at how we can do that right in the early stage. So one of the things was doing simulations of a car in a crosswind. So this is a car going through a crosswind, and it deviates. And those thin lines are actually a motorway lane. So that car deviates out of the lane. And that's a very classic engineering approach. We've just proved that the car moves, but we haven't really got much further than that. So what we need to do is introduce the human. So what this is where we've put the simulation into a simulator of the aerodynamics and then got a driver to unknowingly encounter a crosswind and figure out how the driver behaves. So we then get the driver behavior. And in this case, we've just got four drivers. And then we use this machine learning reduced order model to turn that into the way the driver behaves. Now, at this point, this was our simulator, but the reality is in the modern world is the manufacturers have enough data coming off the vehicles that if they wanted to, they could probably pull this data off their fleet of vehicles and analyze it themselves and figure out how drivers behave in a crosswind. That's probably perfectly feasible at the moment. So ultimately, you can then end up with this block diagram, which is essentially aerodynamics, vehicle dynamics, the wind and the driver all working together. So that you can then do other things. So this is an example of a vehicle overtaking a truck in a crosswind. And so believe it or not, when they produce the prototype vehicles, they take them out on the autobahn and find 150 miles an hour big trucks to overtake and check the car is safe. So this is like a risk reduction. So the poor test driver's got a little bit more confidence in the behavior of the car the first time it happens. But I'll come to it later. But essentially, the thing is can when we do this, reproduce the real characteristics? Are we kidding ourselves? All these reduced order models and things, do they really behave together? So the second example I'll talk about, which is perhaps a little easier to understand, is advanced driver assistance systems, known as ADAS. So there's a lot of interest in autonomous vehicles, fully automatic. But that's not going to happen for a long time. And what you're getting in your cars nowadays is quite a lot of discrete systems that will help you. They're assistants. They're not to drive it for you, but they're to assist. And so typically in your car, you've got various sensors like radar, LiDAR, cameras. And the two I'll sort of mention are the autonomous emergency braking, because that's a radar in the nose. And if the car detects that you are going to crash into the car in front, it will start warning you. It will then start pre-tensioning the seat belts to pull the seat belts tight. It'll then pump up the pressure on the hydraulic lines for the braking. So when you do brake, you're going to brake a lot harder than you expect. And if you don't brake, it will put the brakes on for you. But if you think about that, that's quite a complicated set of decisions to make that you don't want to happen incorrectly. You can't have this accidentally going off on the motorway randomly because someone else will hit you from behind. So that's quite a complicated system. And the other one, which I'll show examples of pedestrian detection. So at low speeds, the cameras are looking for pedestrians that are going to come across your field of view. And as a driver, when you're driving in busy traffic, you're often focusing quite far ahead. So a pedestrian quite close to you is not necessarily that easy for you to spot, even though they are physically quite close. So the real problem is, we can design these systems, we could figure out the algorithms, but how on earth do you test? And actually the way you test is you can't obviously use real people, so you have to use some type of dummies. So this is some sort of public domain testing. And this is what should happen. So the driver's doing nothing, the car spots the dummy, and notice the dummy has walking legs, you see, because the cameras are looking for people walking legs. If the legs aren't walking, then the person's not moving. But this is what happens when it doesn't work. Now, clearly, as a driver, you should spot this pedestrian. But if you weren't looking, the system, for whatever reason, and these are cars that were tested in the US that were available. This is not a manufacturer. These were cars that people use at the moment. And in certain scenarios, they just don't detect pedestrians. Probably enough of that. So the point is that, okay, how can we do that better? And essentially the way the industry is looking is to try and do that testing and simulation, because that testing you maybe do 10 in an afternoon. But if we can do it in simulation, we maybe do 10 every second. So this rather complicated diagram is essentially saying what I said early on. We need to know about the vehicle dynamics, the environment, rain, mist, etc., dirt on the windshield, sun position, because that may obscure the camera. We need to know how the camera optics work and everything else to simulate the whole thing, so we can test, does the vehicle spot the pedestrian or does it not? And if it doesn't spot the pedestrian, we can then go around the loop of training the system and getting it better. So this is the great hope, because the reality is you can't do real world testing of ADAS because you can't put real people in front of cars that are coming towards them. So this is obviously quite critical, because these are products that you may well be driving in the future. So really the questions I want to leave with is that what we're doing in engineering is creating these fast models that are based upon real physics, but it's machine learning. And so do they really produce reality all the time? Do we get some cases that don't? if we couple them all together, do we really predict the correct system behavior? We think we've got these fantastic models, but maybe they don't quite predict the way the car behaves. And a more public thing, is it acceptable to validate safety systems with no real world testing? And I think the odds are probably no. You need some real world testing, but in some respects, it's a sort of a sign off at the very end, just a double check rather than as an overall part of the vehicle development. So I'm pretty sure there's quite a lot that I've done quite quickly, but hopefully that was of some value.
That's great. Thank you, Gary. Some really interesting points there. So we will now pass along to our next speaker, Joel Walker, who is COO at the Knowledge Group, and he'll be looking at AI in logistics.
Good afternoon, everyone, and thanks, Will, for the introduction. It's a pleasure to talk to you today. I'm a COO today of a digital procurement company, but for the previous 10 years, I was global head of procurement at Vodafone, where I looked after a number of different categories of spend, a couple of billion euros worth of indirect spend, lawyers, accountants, financial services, contact centres, fleet, travel, cars, all manner of interesting things the team are buying. And that background at Vodafone, which was a pioneer in digital procurement, has helped in my new role as we build a specialist procurement advisory organisation to help businesses buy things more intelligently. Clearly, artificial intelligence works wonderfully where there's good, solid data, and in the procurement space, it's certainly an environment with good, solid, structured data. So I'll step you through the slides. We've got a chance, I think, from Will at the end of all of our presentations to jump in and ask questions. I think I've touched on that already. It's just a few words on us as an organisation. What I really wanted to talk to you about today was the sort of accelerating role of technology in the procurement space. So the different domains within procurement, be that spend analysis, prioritization, actual sourcing of goods and services, as well as the sort of end-to-end procurement processes. There is a rapid evolution of the application of technology in those areas, but those use cases, those solutions are developing at different speeds. If you look at the left-hand side of the screen here, you'll see what we'd recognise as, we'd call them sort of core solutions, which pretty much it means that they should by now be very well adopted across most mature sort of organisations. And those are things like spend analytics, e-sourcing, e-invoicing, contract management. Those are the things that you will have seen and heard about over the last few years, and the sort of adoption of those is pretty much mainstream now. So I don't think we'll come on in a second to talk about the actual AI use cases, but I think it's important just to recognise the sort of the differing states of evolution in this space. What we're starting to see mature now, and there's been considerable investment. There's been a little bit of the emperor's new clothes, but what we're starting now to see is some real innovative solutions developing that are employing AI or machine learning into different areas of procurement. So product marketplaces, crowdsourcing of different goods and services, predictive analytics. So again, building a little bit on some of the topics that we've heard earlier today, where you start in a supply chain environment, which has been increasingly disruptive over the last few years with pandemics and other global challenges. The ability of a supply chain to react needs a level of intelligent support, which clearly AI is starting to encroach on and provide support to individuals. I think the last piece where we're not yet seeing such a development yet, but is in the more sort of emerging solutions. So bringing that collaboration and social responsibility, how procurement organisations are driving for value, not just savings, and how ensuring that supply chain is sustainable. So I guess this is really the meat of the content, and to save you all diving in and trying to read it off, I'll try and lift out. I'm not here to read the slides out to you. I'll try and lift out a couple of those, the key points. So the benefits of that technology we're increasingly seeing now across those different domains that you can see at the top. So in the sourcing space, ensuring that suppliers have the relevant levels of accreditation and certification, there are tools and technologies available now that are able to be configured to set up to monitor organisations and alert and request human intervention where sort of further scrutiny may be required. Within the contractor management space, clearly there are huge amounts of cost and a number of solutions starting to develop now where solutions are able to learn how to read contracts to start to extract key terms and conditions. So if you're in an M&A environment and you're provided, hundreds of contracts in a data room, there are now some interesting sort of AI-enabled solutions that allow you to very quickly digest and understand the implications and obligations that you may well be taking on in that merger and acquisition. Similarly, the risk management, the monitoring capabilities that AI offers, and the understanding and the ability to convert contractual content and real world activity in the form of SLAs and KPIs, having that data managed, manipulated, and presented back to an audience in an intelligent way. We're seeing again more and more solutions in this space start to develop. I think the last couple of dimensions where we're seeing an increasing sort of use and adoption of that smart technology is in the complementing of staff's decision making. So introducing almost autonomous based procurement support used for very simple use cases, which frees up staff for some of the more complicated activities. But similarly, those more complicated activities, you can use a different profile of staff if they have the relevant supporting technology. And again, we're starting to see that guided buying experience through different procurement platforms, Maestro being one of those, but other solutions are now starting to emerge that guide users through that procurement journey and enabling a better buying experience for customers. I think in terms of where we've got to, I'll pass back to Will. Hopefully there's been something there that's resonated around the sort of growing use of AI in procurement, but I'll pass now, I think, to Sue.
Yes, thank you, Joel. We'll hold questions to the end just to ensure that we get through all of our presentations. But yes, Sue Williams, who is the Managing Director of Hexagon Consultants, here to talk to you about responsible and ethical AI usage.
Sorry, schoolgirl error, not coming off mute there. So good afternoon, everyone. Thanks for joining us. So my engagement with AI, again, I'm not an AI expert. I work with it in two ways with our clients. One is helping them navigate the space of how they can use and apply AI in more of a supply chain and operations environment, which is my background, but also using that to understand and take the concept of digital twin in product design that Gary was talking about and taking that out into the broader business applications, particularly around design and optimization of supply chains, and then clearly navigating that in a responsible way. So a couple of different dimensions for me, but so not an expert in AI, but very interested in its application in industry and B2B environments particularly, and also making sure that we're doing that in a way that doesn't bring risk into an organization. So AI, as I think everyone's discussed really, and we know it's got huge potential, but it also carries huge risk. It's got the potential to be biased, insecure, break laws, violate rights even. And even if it's not got an individual person at the end of your AI, say for HR or for medical use, for organization, it has the risk of significant financial implications or reputational harm. You're already interacting with AI, whether that's through Google Maps or chatbots at the very simple end, but more and more it's becoming common in business applications, forecasting, HR, automation, procurement, as Joel was describing, employee productivity. I have a very long list of things that I think even in my world of supply chain and ops, that AI could be adding value to or already is. However, there's lots of risks with it. So there's a few examples on the slide here where it's been publicly known that AI has perhaps not performed as it should do, and I could have filled this slide many times over. So there is a lot of challenge with making sure that you do it in an appropriate way, but also recognizing that you need to control and think about your design of AI right at the start. And the impact of getting it wrong is big. So what are the common challenges? So there's regulation coming on AI, particularly in the most high-risk use cases. So we're talking about certainly for EU and North America, there are laws coming in about the use and implications of AI, particularly where there is a human at the end of that. So high risk cases might be using it for medical analyses or AI in HR, where we're seeing lots of examples now where AI is being used as part of an interview process. One of the examples on the previous page was Estee Lauder, who were penalised for choosing who would be made redundant using an algorithm. So regulation will be coming around those, but there are also a range of other standards, definitions, best practice. This is an emerging area. Keeping up to date with that is quite tricky as that landscape starts to solidify. If you're buying AI, whether that's through your supply chain or because you as a company want to use AI, you need to think about your procurement processes. And also thinking about, as you start to apply your AI and start to bring that in at scale, what does that mean to your organization and the risks that you're bringing in? And a lot of companies that are either using AI or starting to think about buying AI just don't really understand what this means in terms of the implications and the risks that they're taking. So leveraging other organizations that have gone through that is definitely the best way to go. So the framework I've got on the screen here is from the Responsible AI Institute. So they're an independent, not-for-profit organization that's created a set of assessments and frameworks to help companies manage the risk of AI. There are other frameworks out there, but this is our chosen company that we work with. And I think their framework is excellent on the basis that it's picking up all of the different inputs from North America, Europe, and others, bringing that into a structure and then testing that out across a community of experts and key use cases. So we're talking about here using the framework to assess a number of dimensions of AI. So we're looking at data and systems operations, explainability and interpretability, accountability, the consumer protection, making sure you've really thought about any implications of bias and fairness, and also ensuring that the AI that you're either procuring or implementing is robust. So it's strongly recommended that you embed the concepts of responsible AI at the start of your AI journey. I mean, it may be that some of you as organizations are already implementing or procuring AI, but there are things that you can do. And again, I'll refer you back to the Responsible AI Institute website for further information on some of their frameworks. But there's things you can do around your own governance and infrastructure, so your organizational maturity, thinking about your procurement processes, and that could be for you buying AI or where you're using an organization such as Joel's that may be using AI on your behalf. So it's about thinking about where AI pops up in your supply chain and in your organization, and thinking about the processes and infrastructure that you need to put in place to manage that risk. It costs more to fix issues than it does to prevent them. And then the reason that I think it's particularly important is there is a lot of information around now that says AI really does help businesses succeed. It is really pushing boundaries on analysis and being able to assess options and the best use of your design resource or your investment capital or whatever it is that you're looking to do in terms of your business decision making. And as demonstrated by the Accenture report I refer to here, these AI achievers are already generating more revenue growth than their peers. And it's becoming more accessible, lots more opportunity for smaller businesses and medium businesses to access and use AI through service providers or through different routes these days. However, it really is important to put that responsible thought process in at the beginning. And definitely there is a further benefit from the Accenture report that they are 53% more likely to have applied those responsible AI practices from the start and at scale. So these successful companies have got responsible AI baked into their approach. So definitely a message that I'd like to leave anybody considering the application and use of AI with from here. So again, I'll hand back over to Will for any questions.
Thank you, Sue. Okay, so we're going to move on now to the final part of our webinar, which will be the panel discussion. I just ask that if anyone does have a question, if you could put it in the chat, and then I will pose them to a panel just so we can keep everything in order. But yeah, if you'd like to start formulating any questions you have now, we'll pass them along. And if you have someone specific that you'd like to address it to, if you could just include their name in there too, it would be great. And just while we're doing that, one pre-prepared one we had before this was thinking about what you were saying, Gary, with regards to cars, stopping distances, things like that. It's been quite prevalent in the media lately, and feeds in somewhat to what Sue is saying about, responsible and ethical AI. I don't know what your thoughts are on with things like simulations. Obviously, there is a big challenge here with persuading people that that is a viable alternative. And do you think, in the near future, companies who are experimenting with self-driving things are going to be able to win people over, particularly if they aren't doing, as you say, real life tests? There is a certain perception that perhaps they are putting people at risk by not doing that.
I think the first thing is, the car companies are very professional and won't take huge risks with products. They understand that if they produce a product that has problems, it can literally cost them billions. And the Volkswagen Dieselgate is a good example of that. Can almost destroy the company. So I think they will be, by definition, very cautious and not move too quickly. I guess the difference was if you have sort of more startup type companies, and Tesla's the obvious example, that are willing to take more risks, and they certainly have with our sort of so-called autopilot, which is anything but an autopilot, that can then be damaging to the rest of the industry. So in some ways, Tesla have done some great things, but the autonomous stuff they've done is probably actually, in some respects, a negative impact on many people. But again, the whole autonomous vehicle testing, I think a lot of people are looking at, well, again, we need to do it in a simulation, because when you work out the number of miles you need to drive on the road, all the different examples of things you need to test, it's incredibly expensive. You've got to get that mileage. So if you can do some of that mileage in the simulation, then again, you can just increase your confidence.
So we've just got our first question in from Adrian here. And he's asking, is AI just a modern take on what we used to call expert systems, or are they fundamentally different? And open it up to the panel, whoever would like to take a crack at that to begin with.
Well, I can pick up on my bit, because in engineering, it's definitely not. The expert systems, in the old days, basically asking a series of questions and giving you an answer. In engineering, we're using it very much as a way of characterizing data, in particular, in terms of capturing data. So it's a machine learning process. And in terms of a lot of the autonomous stuff, it's artificial neural networks, which in theory behave like the brain, but are not really. But they're sort of pattern matching. So that's actually one of the issues with the autonomous vehicles, whether they spot people correctly, because the pattern matching doesn't work. But no, so in terms of engineering, it's definitely not like the expert systems. But AI as a whole could include that.
Sure. Just to pass over to Joel for a moment. talking about logistics and procurement. In that context, obviously, recently we've had the pandemic, we've had the war in Ukraine, the Suez Canal issues. Looking at things like AI, obviously they are fed off of the data that we have available, which is historical data. To you, is it viable to be able to predict those kind of things based off what AI knows and the data we have available? Or do you think, there's always going to be a certain amount of, we can set up the system, but we need to have it adaptable to deal with, what I call black swans, but are becoming increasingly more likely?
It's a great question, Will, and I'd love to say yes, although I think the real world evidence that the audience have seen around, systemic supply chain failures across the board over the last few years would suggest that despite, the increasingly prevalent use of technology and AI, particularly AI in predictive analytics, I don't know that I don't want to get into a party political conversation, but I think the implications of Brexit, of wars, of the pandemic, and I'm not sure that those were accurately modelled and forecasted with AI or alternative technologies. That said, I think businesses and organisations' ability to react to things, so in a reactive way rather than a proactive way, I think that technologies were allowing the organisations to start to do a lot more intelligent what-if scenario planning than. So I think it was less. I think the technology failed us in terms of predicting a number of those outcomes, but I think it has supported our reaction to a number of those events.
So I'm just going to go to you, Victor, now. I can see you've got your hand up over there, but just before you crack on, we've also got a question that kind of feeds into the area you were looking at anyway from Jill here, so perhaps you can move into that afterwards. And she's asking, is there research that is needed on the human side of AI around, the attitudes, the perceptions people have of it, the decisions of where to invest and how to apply it? And that's your area, I believe, Victor.
Thank you. So first, to go back to the expert system and AI and such, expert systems are one form of AI, okay? Neural networks are a different form of AI. There is a third one, and there are some hybrids. It doesn't really matter. But what is very important, it is not the same. Various forms of AI seem to kind of have this step change in which is popular at what point. However, if you look at some incredible AI successes like the AlphaFold by DeepMind that was creating these protein structures, they don't talk about it, but it is actually hybrid AI. It has an expert system component. That's why they gathered all those experts to include someone in how, for example, the goal function is formulated for the neural network. Okay, so there is a big chunk of it, which is neural network, but there is a little bit of expert system working with it. And the expert systems in that old form of just asking questions, they are not only rule-based systems, there is machine learning in expert systems as well. It is a different way of machine learning, and of course, each of these has advantages and disadvantages. But I think that it is just kind of the current fashion, because for certain things, neural networks work fantastically well. The other thing is that, as in any modeling, we can only model what we understand. And this is why what we have currently in, for example, artificial neural networks resembles what we knew in the 50s and 60s about the neuropsychology. Okay, so we know far more now, but it did not make its way into the world of AI yet. Okay, so I think that these points that the other speakers were making are very, very valid, and we need to pay really a lot of attention to that. So all the responsible AI and the rest. Sorry, what was the other thing, Phil, that you wanted me to talk about?
Yeah, so the other element was obviously InterAct. We don't look at purely the technical solutions. We're looking at the broader social and economic consequences, and one of those is, what human insights can we learn? So what's your take on do we need to do more research into how humans interact with AI and what their attitudes are when using it? Earlier Sue was talking about how people perceive AI, and that could shape the way that they want to use it. You were saying it can be a tool, an assistant, or a sounding board. I think a lot of people still think of it as a robot that you tell to go and do something, and it goes and does something.
Yes. Yes, of course, as my presentation was about that exactly because I believe that it is very important. So that's why I am doing research in that area. How people want to and how they do interact with AI and how they perceive it. Very often, the whole point is that if you look at, for example, these various Turing tests that happened, if you look at the text, for example, from the Eugene, the 13-year-old Ukrainian boy that passed the Turing test at Manchester a few years back, and if you look at that text, you would not believe that it is a human being saying those things. Okay. However, when you are in a process of conversation, you as a human often bring the meaning in, even if there is no meaning on the machine side. So the first ever program that passed the Turing test was a software called ELISA, like in the 60s, so very, very long time ago. And out of all areas, it was a psychological counseling software. So you called it, I have some bad thoughts about my father. And then the software had a very good grammar analysis module, which identified which is the noun in your sentence. And then it asked, okay, so tell me more about your father, because it identified father. If it was could not identify the noun, it tried the verb, asked you about the verb or an attribute or something. But the most ingenious was the if else rule. The else was the absolute genius one, because if it could not figure out anything about grammar, it said, I perfectly understand you. And eventually you continue talking. So people did not notice that this was a machine, because they brought the thinking, the meaning into the process. So yes, looking at the human side is enormously important. Sorry, maybe too long answer.
No, thank you, Victor. I'm just going to bring in Sue now, because that's quite interesting. Sue, what's your perception on obviously how that applies in a business environment? People bringing in these new technologies, they're carrying their own perceptions, and particularly at a higher level, they may have been working in that industry for some time and have their own views on how that's going to slot into their business model.
Yeah, and I think just to pick up the point around the human side of AI, I think the research is ongoing, but the reality is that AI is moving more quickly than the research is. Therefore, this is why a lot of governments and other bodies are looking at regulation or some form of guidelines and frameworks to support the application of AI and the human impact, because otherwise it will be too late, because it's moving so quickly now. And I think bias and fairness is crucial. So I've been involved in probably what would have been the forerunner of the current AI systems and modeling supply chains. And I've been involved in scenarios where we have been setting up models to look at a particular flow of activity, and someone said, well, it's going to go. We need to put this in, and we're like, well, why would you do that? Because that will immediately send it off in a particular direction, or they're using their own experience rather than being analytical and trying to set the machine up to do something. They will bring their biases with them, and they can't help that. That is a natural human reaction. So that is a reason for ensuring that you're bringing those responsible AI frameworks into your organization, to make sure that you're doing your very best to test and assess for those biases and fairness checks, to avoid either something like the Zillow example, where it was purely a business algorithm. This was not necessarily impacting humans, but they were using an algorithm to determine which houses to buy that were currently being sold for below market value. And the algorithm got it wrong, and they ended up spending stopping and having to shut down almost the whole business because they'd ended up paying well over the odds. And that was as a result of an inappropriate use of an algorithm. If you extrapolate that across to a HR application, then the implications are huge, both on the people affected, on the organisation, and reputationally and financially.
Thanks, Sue. Yeah, no, there's some really interesting points. I think, it's, as you mentioned at the start of yours, it's a very question thing, particularly with the way that people are sorting through that data and the implications. But, I think we may have all seen things about how do we perceive robots? How do we use facial recognition software and not being able to pick up people who are dissimilar to the programmers who were testing those things? So
definitely.
We've got another question here from Chris, and he would like to know, the presentations have shown a wide range of application cases, but how is the AI industry as a whole grouped? Is that by application, by industry they serve, or in another means? I appreciate that's quite a broad one and probably quite a difficult one, given that it is a fairly new technology and these things tend to settle in over time. But if anyone would like to take a crack at it.
Well, I can talk about it through the lens of how the responsible AI work is it's being grouped by its use cases in the majority. So we have specifics around finance use cases versus healthcare versus say HR or others. And then what we'll end up with is groupings that are where the AI is doing a particular kind of analysis or where there's a particular set of potential harms. So that's the kind of work that the groupings that we're seeing through the assessment frameworks. I mean, in terms of the design and development, that's definitely not my area, but certainly from a monitoring of it's really about grouping it by application and impacts and potential harms.
Okay, yeah, I suppose my takeaway from that, perhaps Joel and Gary could weigh in briefly here. For the layperson's point of view, working with procurement or indeed automotive design, do you find that it is you would have a specific AI firm who is looking at that specific industry, or is it more broad strokes businesses who are kind of delving into different areas and trying to apply that technology in different but similarly applicable ways?
Gary,
John, if you
first. I'll go first then. So I think this is a very specialist area, and I think it's important. The attendance at today's webinar is probably a reflection of people's interest in understanding what the future looks like, and understanding will only come through a debate on topics such as the ones we've covered off today, and learning from each other around the practical applications and implications, as Sue raised, around the sort of growing adoption of AI in different industrial contexts. To come to your question specifically, Will, around how it's bought, I think the one theme I haven't heard come through yet, and it does resonate a lot in the procurement space, is around how the biases can be accounted for in terms of the establishment of the algorithms and the intelligence that starts to scour and the marketplaces for pricing information or supplier intelligence or available providers, etc. I think this needs intelligent people to invest time and effort in building ecosystems, building wide solutions to address very complicated topics like how to apply this technology into organizations, particularly in the procurement environment, but also in which is an area I'm very passionate about, but also, of course, in any other area. I think that it's the one thing I've not heard perhaps touched on enough yet. I don't know if Gary has got some different reflections to that.
Yeah, I mean, I think I come from a fairly different perspective in terms of engineering design. I think the engineers view it as just another tool to do the job better, and it's something that a lot of promise, but it is ultimately just a tool to do a better job. But it's part of a bigger trend, because in some respects the reason why particularly machine learning has been launched so much in the last few years is because the internet generates so much data for these companies to then use and train. So Apple have got all these photographs they can run through image processing to figure out various things. And the same is true with cars and with aircraft in terms of the modern car generating a lot of data for the companies then to analyze, to understand how it's used by their users. So at the design process, you can actually produce a product that matches what the users want, because they can see all the data from that. But there's an ethical thing there, because you may find with a modern car that you are, just like on a web page, agreeing to certain things, you're agreeing to certain disclaimers to give up your data that you're generating on that car as well. In terms of some of the companies, I've seen some companies have got their own little sort of AI type groups within the company that are there to sort of act as like a nucleus and to support people. But to be honest, the sort of feedback from the engineers on the ground, they didn't see those terribly useful. But that's the other way of doing it, is setting up a new sort of group that will then support the engineers so they can do their job and the specialists can then help them do that job.
Right. Well, I mean, the next question is also up to you, Gary, and it's quite a hot button one that has been in the press recently, and it's from Kuldeep, who would like to know, perhaps this is more of an ethicist or a philosopher's question, but he'd like to know that given that automated vehicles are supposed to be safer because they eliminate a lot of human error from the driving experience, at this stage, we're not suddenly going to have everybody on the road in an automated vehicle. They've still got to interact with other human road users. So if there is the situation where there was some kind of crash between an automated vehicle and a human road user, who would be liable for that? Is it the person who owns the automated vehicle at that stage, or do you think it would be the company, or would it only be the company in the event that the engineering had somehow failed?
The statements in the industry are very much the company would be responsible. I think we're a long way from that. And as you sort of hinted at there, the difficulty is that transition. And I think that's what a lot of the autonomous companies have realized. It's hard to get that transition. If everybody had fully autonomous vehicles now, life would maybe work. But when you've got things that aren't and are behaving oddly, and the other thing they've realized from a lot of testing is when people come across an autonomous vehicle, they try and test it out. They drive badly to try and see if they can make it stop and things like this, or people jump out in front of it and things. So, but yeah, ultimately that's where they want to go to. If you can get the rates down so low that the company then can tolerate that in terms of potential liabilities, then that's where we're going. But I think it will take a while. And obviously things like insurance companies are a big issue in this. So that's why I think the fully autonomous is much more challenging than we imagined, unless you have very well-defined things that are isolated, certain type of things where you've got, like the demos they've done in Greenwich, things where you've got things that are not interacting with other people too much, and you get the experience that way.
That's great. Yeah, I think that's quite interesting as well there, that you're saying about people testing autonomous vehicles. It does speak to a certain discomfort that people still have, with AI, whether it be in the workplace or the environment. How do you understand this machine, and is that human understanding there? Because then you'll know, I don't need to throw myself in front of it. I know it's going to stop, but I think people are wary, and in some ways that manifests a bit strangely. Okay, so we're just going to go to the last question now, and that's from Suleiman, who would like to know, how can we use AI to research AI, which is a bit of a Ouroboros, I think. So, Victor, perhaps you'd like to start us off as a researcher in the area?
Yes, I think that in many ways we are approaching that limit where we cannot study AI without AI. So if you look at the largest neural networks today, they are so complicated, and they are not necessarily complex, but they are definitely complicated, that we simply cannot even look at all those connections and such without using AI to analyze AI. And that is getting tricky, okay? So for all the reasons that were previously mentioned about how people are testing AI and so on, whether the car will stop. But there is also always kind of the other side of it. So, for example, we have these statistics that show how many, accidents are caused by human error. And that we can use as a case for self-driving cars. However, we don't have statistics about how many accidents have been avoided based on human skill, and we cannot have such statistics because the accident did not happen. Okay, so that is always much more complex than we would like to think. And very often when it comes to AI, we simply don't understand what on earth is going on. So for example, one of the best working areas of AI are image recognition. Now, some guys at Google who are building the image recognition, they also were playing with it, trying to see what kind of mess they can create. And imagine when there was a picture of a lion that AI correctly recognized as a lion, and then these guys changed 3 pixels, which you don't notice, and then the same picture by the same AI was recognized as library. We have no idea how this is possible, okay? So yes, then you use AI to investigate this, to figure out something, but we are very, very far from that. And that's why I think it is very important to listen to people like our speakers who are cautioning about the pace. Because there are some who want to implement, I don't know, self-driving cars tomorrow, and then, I don't know, ethical policing and such the day after tomorrow. And these are not ready.
Okay, thank you, Viktor. I'd like to just bring in finally on this one as with the focus on ethics and responsibility, Sue here. I know that raises some interesting questions on accountability, I suppose, if you're reaching the point where you're researching AI, using AI, and as Viktor says, these networks are so complicated and there's so much data. I suppose from a business point of view, if something does go wrong and you're almost backtracking to this far off point where no humans have been involved, do you think that is perhaps off-putting in some ways to people who want to innovate? You know, a lot of places would say the legal implications of it might be not worth the benefits that it brings.
I think that the reality is some of these capabilities will be a black box. There is it's very difficult to open up and interpret exactly why it did what it did in terms of its decisions. But it is really important to put the frameworks around it that have the right checks and balances at different stages in its use, because even over time, you can't just put something in and then leave it. You've still got to keep those checks and balances in place as you continue to use any form of AI. And then making sure that it's not even through its use drifting off and starting to introduce bias or doing something unexpected. So whilst AI has got infinite potential, it has to be managed and also thought through in terms of its application and the appropriate point for its application, which is why governments and other bodies are stepping in a number of areas to ensure that the right controls are put in before people get overexcited and take it too far before it's ready.
Okay, thank you very much. Well, that's going to bring us to the end here today. We have overrun a little, but hopefully you all found that interesting enough to justify the extra time. Just like to thank all of our speakers for coming in and giving us a little bit about what they do and how they relate to AI today. Obviously, I'm sure they would all be happy if you have any more detailed following up questions to get in contact and discuss. From our perspective as InterAct, a lot of those later questions particularly really touch on the areas that we're looking at. We aren't, experts in the specific technology, but as I mentioned earlier, that we are looking at the wider social and economic implications of these technologies being introduced, and hopefully our research will help to answer some of these questions in a more definitive manner. If you would like to find out more about what we've got coming up, as I say, please do visit our website, join our mailing list. We keep everyone abreast of what's going on our weekly monthly newsletters rather. And then just a final message now from our funders, ESRC. They just wanted to let people know, if you are interested in AI and you are working at a university, there is an opportunity coming up for funding for centers for doctoral training in artificial intelligence. And as you can see there, they're covering a number of topics. And once again, it's less about practical lab research into the technical aspects of AI, and it's more about what are the wider implications of AI in these areas. But if you'd like to find out more, please do go to their website and investigate. I'm sure they'd be happy to hear from you. So as I say, once again, thank you, and we hope to continue to interact in the future.